Students, today let us verify one theorem from class 9th, that is angle bisector theorem. First of all, let us have the statement of the theorem. Every point on the bisector of an angle is equidistant from the sides of the angle. Now we'll illustrate this by using a diagram. Suppose in this diagram angle PQR is given, and here ray QD is the angle bisector of angle PQR. If it is so, and if there is point A on this angle bisector, and if we try to find the distance of point A from two sides of angle, that is angle PQ and angle QR, so as we can see, AB is perpendicular to side PQ and AC is perpendicular to side QR. That's why AB is the distance of point A from PQ and AC is the distance of point A from side QR. So if it is so, if there is any point on this angle bisector, then it must be equidistant from the two sides of an angle, that is AB is congruent with AC. So now we are going to verify this by using Geogebra. So let's move to Geogebra. This is our Geogebra interface. We have to verify angle bisector theorem. So first of all, we must have an angle. So click on angle icon, and we can draw an angle of any measure. So these are the 3 points on two sides of an angle. Now to draw the angle, we must draw two rays which starts from point B, because B is the vertex of that angle. So we have here a ray icon, click on that. We have to draw ray BA, so that's why we have to start with point B. So click on point B, and then on point A we get ray BA. In the same way, click on point B, and then on point C we get ray BC. So the measure of this angle is 65.71. So this is the angle we have drawn, angle CBA. Now to verify the theorem, we must draw an angle bisector of this given angle. Now we have to draw the angle bisector of this angle CBA. So we'll click on the 3 points which are there on angles, that is first we'll click on point A, then we'll click on point B, and then we'll click on point C. First to get one line which passes through the vertex of an angle. Now this is the angle bisector of angle CBA. Now we have to take any point on this angle bisector. So for that, click on point icon, then click on anywhere on this angle bisector. Now we have to measure the distance of point D from two sides of an angle, that is side CB and side AB. So to do that, we have to draw a perpendicular from point D on the two sides of an angle. So for that, we have here perpendicular line option, click on that. We have to draw perpendicular from point D. So click on point D and then line AB. So we get here perpendicular drawn on side BA of angle CBA. In the same way, we have to draw perpendicular from point D on side BC of angle CBA. So to do that, click on point D and then the side BC of angle CBA. So here we get a perpendicular which is drawn from point D to side CB. Now we have to fix these 2 points of intersection. So for that, click on point icon, have one point here, point E. The point of intersection of this perpendicular line and the side of an angle is here. We'll click here, get point F. So here segment DE and segment DF are nothing but the distance of point D from two sides of an angle. Now we are going to measure this. For this we have distance or length icon, click on that. So firstly click on point D and then on point E we get the distance D as 3.56. In the same way, to find the distance DF, click on point D and then on point F we get the distance DF, which is again 3.56. So here the two distances DE and DF are equal, that is 3.56. That means point D is equidistant from these two sides of an angle. So this is how we have verified here the angle bisector theorem. I hope you understand this concept.